Okay, so welcome back, and now we're going to do an application example. So in this example, we're going to be dealing with harmonic motion. So we're talking about, this is the equation for the velocity of an object that is experiencing harmonic motion on a spring. Okay, so it could be where you have a block, right, and it's sliding on a frictionless surface, and it's attached to a spring, which is also attached to a wall. And so if you pull it not too far, obviously you don't want to bend the spring, but again, if you pull it to a certain distance and let go of it, it'll slide back and forth in a harmonic motion. Or if it's hanging down from a spring, you can pull on it and then it'll sit there and bounce up and down. Either way, you can represent the velocity of the object by this function. A is what we call the amplitude. It's the maximum distance that the block travels. Okay. K is the constant, what we call the spring constant, based on the properties of the spring. M is the mass of the object, and then T is time in seconds. Mass is in kilograms, and then the distance usually is whatever, centimeters, inches, whatever the case may be. In this case, I'll have to read the problem. But let me read that to you so we have the setup. Okay, so it says, it's measured in centimeters. Okay, so the maximum distance of the object is, A is measured in centimeters. Okay, so now, it says, find the velocity of the object after 0.100 seconds of a 36.0 gram object at the end of a spring which has a spring constant of 400 grams per second squared if A is 5.00 centimeters. So in this case, the object is being measured in grams. Okay, so what do we know? We know T. So T is equal to 0.100 seconds. Okay, what else do we know? The mass of the object is 36 grams. Okay, we also know that A is 5.00 centimeters. And what else do we know? Oh, in K, the spring constant is 400 grams per second squared. So K equals 400 grams per second squared. Okay, now, also, actually this whole thing is the amplitude of the cosine function. Okay, so I misspoke. This whole thing, this is the maximum distance, but notice that these are the same. If you ever take a class in differential equations, you'll be studying this quite a bit. Okay, so this is something you'll become very familiar with. So we've got this, so this here, but then here we see that this is the angle. Notice that that's the angle, okay? And so what we're going to do is we're going to take the information, plug it in here, we're going to find the velocity of this object, okay? So let's do it. So basically this is just going to become a plug and chug. So this is going to equal 5.00 times the square root of 400 divided by 36.0 times the cosine of the same thing, 400, square root of 400 over 36.0 times 0.100. Okay, so now all we have to do is just put this in our in our calculator. Okay, now, what is it measured in? Okay? Let's look at this angle. This is in seconds. This is the square root of what? This is, again, measured in, let's do some dimensional analysis here. So K is grams per second squared. Mass is grams, right? So if we look at the ratio here, we've got grams divided by seconds squared divided by grams. So the grams are going to cancel out and we're going to get 1 over seconds squared. But then if we take the square root of that, we get 1 over seconds. And then we get 1 over seconds times seconds, which then cancels each other out. So we end up with a unitless measurement. So in this case, we are going to treat this like radians. Okay? This angle has no units, so this is radians that we're dealing with. So we got to make sure our calculator is in radian mode. Okay? So let's check. And mine is. Okay, so now that's in radian mode, now I know I'm going to get the correct answer when I plug everything in. Okay, and again, if you look at this here, if you look at the dimensional analysis here, this is just going to give us a number, right? This is again just going to give us a unitless number. And then if you do the unit analysis here, you find that you get centimeters per second. Because this, again, just like over here, this is going to give us 1 over seconds. This is centimeters, so we get centimeters per second. It works out. We get velocity, which is exactly what we want. Okay, so now, let's plug and check. So 5 times the square root of 400 divided by 36 times cosine of and so we get 15.75 rounded to the hundredths place. So again, we're going to round to 3 significant digits. So that would be 15.7, right? Sorry. Oh, let me fix that. That's never happened before, right? Okay, sorry about that. Okay, so now, what do we get? We get 15.7 centimeters per second. Okay, I forgot what I was saying before, but this is the answer. Okay. Have a great day.